transformation. Yay! That's transformation. Well, first thing I have to redo is rewrite this guy and put the function in front. So this is the opposite of 3e to the 2x plus 7. So now it's in transformation format. Now, for those of you going into the business calculus, we deal with e. Essentially, everything that we do in calculus is with e. We do a little bit with like 2 to the x or 3 to the x, but that's fleeting because your business examples all deal with e. And so if I list the transformation, if I start here, what is that transformation? Horizontal. Because it's in where the x's live. Anybody remember what that is? 2 times x. It's not a stretch. It's got to be yeah, it's a horizontal shrink. Because it's horizontal, it's going to be a factor of 1/2. Remember, it's 1 over is always the reverse of what you think it is when it's inside where the x's live. And then I come out here, and I've got 2 things going on. I'm now on the outside, so I'm finished with the x's. I now move on to the y's because I'm outside. And what do I have? A reflect, the x-axis, and then what?
Vertical stretch of 3.
There we go, vertical stretch of 3, and then what?
Up 7.
And up 7. See, when you're on the outside, it is what it is. When you're on the inside, it's the reverse of what it is. So if it's a plus, it's a minus. If it's a minus, it's a plus. If it's a 2, it's really a 1/2. If it's a 1/2, it's really a 2 when you're multiplying. So the basic function in this case is going to be y equals 3 to the x. The domain, of course, is all real numbers, and as an HA at y equals 0, because that's your basic. So since I only have 1 on the x, I'm going to put this thing right here. This is x, and this is 3 to the x. And remember, we only need 3 coordinate points. The bend in the graph is -1, 0, and 1. So this will be 1/3, 1, and 3. So horizontal shrink factor of 1/2 means I'm going to multiply all the x's by 1/2. So I'll have -1/2, I'll have 0, I'll have positive 1/2. I'm going to smush the graph. Now I'm going to reflect the x-axis, which means I'm going to multiply the y's by -1. So I'll have -1/3, -1, -3. I've just flipped him upside down. Then I'm going to do a vertical stretch factor of 3, which means I'm going to multiply by 3. Remember, you could do it at one time and multiply by -3, because it's a twofer. And 3 times -1/3, that's -1, -3, -9. And I forgot something. I forgot that I have an HA at 0. Now that is not going to be impacted at all by the multiplications, because -1 times 0 is still 0, and 3 times 0 is still 0. And where it's going to be impacted is going to be on the up, down. So then I'm going to move up 7 units. I'm going to add 7. So this is going to be 6, 4, -2, 7. I hope. See, I don't have I know what he's going to look like. He's going to be flipped upside down, and he's going to be moved up 7. But if I take a look at the coordinate points really don't have a heck of a lot of meaning to me till I get them in. But I know he's going to be upside down. So that means I need to scale my y's because I've got an HA at 7. And I'm going to make this 2, 4, 6, 8, 10. And so 7 is going to be about right here. There's my HA. Now, of course, the domain, no matter what, is all real numbers. The range will change. So I'm going to have -1/2, +6. That's right here. I'm going to have 0, -1/2, +6. Where are you guys when I need you? 0, 4. And 1/2, -2. There it is. Now remember, it's a vertical stretch. So it's going to take that nice rounded graph and almost make him look like a straight line. Except as he comes in to the HA, he's going to bend. And then he's going to move away from the HA. This arm right here is very steep. He still looks like an exponential function. Because remember, the basic exponential function always looks like that. But he is flipped upside down and then they stretched him to no end. And so the range is again going to start at -infinity, stop at the HA, which is 7. So it's going to be -infinity to the HA, which is 7. The HA is y equals 7. But he's just very, very steep. And that vertical stretch is what did it.
Am I able to answer everything by the original function? Since I know that it's going to reflect, I know that it's going to be downward, so I already know that where the range is going to be like kind of. And since I know what y is, since it's +7, that's going to automatically be my horizontal asymptote. So I can automatically just go from...
Well, not quite, because you're not quite sure. And like I could say, okay, I mean, I know he's going to be upside down.
Right.
I know this is going to be y equals 7. And I'm going to pull a pencil. It's in my other thing here. But the question ends up being, I don't know how steep it's going to be. And what happens if this is 1, remember that these things are going to be coming down at 1/2. It is -2. So this guy, and at 0, it's 4. So he is really quite steep. What you don't get, I knew he was going to look like that. But what I don't have is, I don't have where that graph and how steep that graph, and he is very, very steep, how steep that graph really is going to be. So you cannot actually get a good look at him without doing coordinate points. I knew that since he's flipped upside down, I knew he was going to look like that. But the problem is, that's not necessarily how he looks, what he looks like on the graph paper.
Right,
How close it's going to be to that y-axis. Yeah. So unfortunately, you do have to go through the process. Because that really gives you a good look at how steep that thing really is. And if I were doing, say, an application problem, and that's where you run into this stuff, is in application problems, and more so on the other end than it going down more that it's going up. And say the population problem. If I had something, and it's very, very different, if I were saying looking at the population problem, you're looking at an exponential that looks like that, right? Now, if I knew it was going to look like that, or if I knew that bottom line, the new HA was here, I know he's going to look like that. But the problem tends to be, does he look like that? Does he look more like that? Or does he look more like this? And if he looks like more like that, and I'm talking about a population growth, this is scary because it's happening very rapidly. Or a bacteria growth, or a growth of a disease. Then this is scary and I might need to be careful. If indeed, essentially what I'm looking at, this thing is kind of like leveling off and going up kind of leisurely, that might say I have more time. So when so I'm actually dealing with an application problem, that makes a difference.